Hey students, welcome back from spring break. I hope you had a great time. I hope you got all the relaxing you needed done. We have April and May here that we're going to power through and make sure we finish this year off strong. So let's take a look at the exam you took right before spring break. We're going to walk through these. You're going to match it up with your exam, and you're going to fill out the form to show how you believe you did and what you can work on. So let's take a look here. The first question says a quadratic function below is shown partially. The vertex of the function has coordinates 3, -8. So remember, you could sketch this in your head or sketch it on paper if you want, but that 3, -8 is the vertex. So if you look right here, we have 3 and -8 as the vertex. What that means is everything on either side of it is mirrored. And so if we go 1 down in x, we get -6. If we go 1 up in x, we should get -6. Same thing here. We go 2 down from 3, we get 1, 0. 2 up from 3, we should have 5, 0. And remember, there's symmetry there. So that axis of symmetry makes the outputs equal when they're equidistant from the vertex. All right. So how do I find this 0? Well, from 3 to 0, it's 1, 2, 3. So I go down 3, 1, 2, 3, 6, 10 will be the same as 0, 10. And -1, 24 will be the same as 7, negative or positive 24. All right. So does your chart look like that? Awesome. If not, what do you need to remember? So what are the roots of the function? Remember, what does it mean to be a root? It means where does it cross the x-axis? And so we're looking for y values of 0. So we have a y value of 0 at 5, 0 and a y value of 0 at 1, 0. So we write them as ordered pairs as 5, 0 and 1, 0. All right. Then what's the y-intercept? Where does it cross the vertical axis? Well, that's when x is equal to 0. And so we have that value right here at 0, 10. So 0, 10. All right. And then go ahead and submit that. So how did you do? Did you get the table right and B and C right? Write those comments down in your survey. All right. Here we go. So now we're going to use this graph to identify the key points. So the axis of symmetry, remember that's what divides this in half. So that's always an x equals line, right? X equals line that's going to divide this in half goes through this point right here at x equals 1. The vertex then is that minimum this case, so that's the point 1, -4. Sorry, 1, -4. The roots, remember where it crosses the x-axis, so we have -1, 0 and 3, 0. And then the y-intercept, so where does it cross this vertical axis? We can see it visually. Boom, right there, 0, -3. All right, so did you get 1, 2, 3, or all 4 of those correct? Type it in your survey, take a little moment to pause and take a look here. All right, so now we're looking at which one best justifies. Okay, so when it opens down, we know this first value has to be negative, and then this x-intercept or the y-intercept comes from that last value of c. So we have a negative here, +8 here. Boom, I know that is the correct answer. Right? You can always test other points here, right? If I put it in 1, do I get back a 10? So you could test that to make sure, but you don't have to. And then justify your response. So you need to talk about, since it is negative, since it is opening downward, the first value by the x squared, has to be negative. And then the y-intercept is 8. So when x equals 0, I must get back y equals 8. And so if we plug 0 in here, right, we get 0, 0, -8. 0, 0, +8, 0, 0, 8, 0, -8. So there's only 2 that would give us the +8, and there's only 1 that has the negative lead coefficient. All right, so that's our correct answer. All right, same thing here. It's opening up, so I need this first value to be positive. Okay, this one's x to the third, so that one's out right away. It's not a quadratic. This is negative, so that one's out. And then it's crossing right here at -2. So which one of these? Positive 2, positive 3, -2. So that's my correct answer for the same justification. So tell me, did you get one of those right? Both of them right? Did you have enough justification? All right. Here's this last question 4. It says an ice cream manufacturer varies the cost of its ice cream tubs to maximize profit. So we have this quadratic, right? And so this is kind of your visualization, your estimation. And so what is the y-intercept of this situation? State the point and label it on the graph. So if you look right here, what's the y-intercept? It looks like it's about -60, right? So it's about 0, -60. And if you're close to that, that's a good idea. All right. Then, what does the x-intercept represent in the context of this situation? Well, remember, this is the cost of the tubs of ice cream, and this is the thousands of dollars in profit. So if we have if our ice cream costs $0, we'd have -$60,000 in profit. And that doesn't make sense, right? So, and if we charge them $0, that doesn't make sense. But if we just gave away the ice cream, we'd lose whatever this y-intercept is. That could be about $60,000. All right. What's the vertex of this situation? Well, what's this high point? What could we guess it might be? It looks like it's about 3, and we get about 50, right? And so we have 3, 50. And what does that mean? It means if we charge $3 per tub of ice cream, our profits will be 50, and it says in thousands, so $50,000. This is our maximum profit. So you can see, if we charge $2, we'd be here. If we charge $4, we're at the same. But if we charge $3, we get that maximum profit. Okay? Here we have this question right here. What are the roots of this function? And so you can see on the graph, we could identify the roots, but it says let's label them on the graph. So here we go. We labeled them. But then we got to justify it by doing it algebraically. And so to justify it algebraically, remember we set each possible side equal to 0. So this root equal to 0 and x plus 3 equal to 0, and we solve those for 0. Here we add 1 to both sides and we get 2x equals 1. Here we subtract 3 from both sides and we get x equals -3. Divide by 2 and we get x equals 1/2 and x equals -3. So we could have 1/2, 0 is this point right here, and -3, 0. And you can see that on the graph too, but you have to justify it algebraically to get the full credit. All right. And then here our last question, create a parabola with one root, sketch your graph. So to have one root, remember it has to start on the graph. So here's one example where it starts on the x-axis, and that root there is 5, 0. So sometimes we have one root when the vertex is on the x-axis. Is it possible for a parabola to have 0 roots? If yes, describe what it might look like, where it's located. So yes or no? The answer is yes. I could do the same parabola. I just move it above the x-axis. You could also have it going down below the x-axis. So explain your thinking. If the parabola opens up and the vertex is above the x-axis, it will never intersect the x-axis, and we will have no roots. All right, same idea if it opens down and it starts below. All right, so there you go. those are your answers. Now, go ahead and look at your survey, answering questions 1 through 6, telling how you think you did, what you still need to work on. And remember, your retakes can be this Thursday, tomorrow, during office hours. All right. Come back to the main Zoom, ask some questions in the chat, and let's really get good at this and prepare for the rest of this quarter.